Hello, and once again I'm going to use the University of Nebraska-Lincoln University Astro Department to actually show 6 characteristics about our solar system and the planets in our solar system. Notice Pluto's green. Pluto's not really considered a planet anymore. 2003 it was demoted to minor planet status and actually opened up a brand new can of worms. So we've got a whole bunch of minor planets now, and the ones we're discovering farther out than Pluto have been going into the same registration as Pluto. First thing we look at is semi-major axis. Very quickly, semi-major axis is created by drawing an ellipse. An ellipse actually is created, if you want to do it on paper, by putting 2 pins in a piece of cardboard, putting a string around them, putting a pencil in the string and drawing it. And if you actually pull this way, you're going this distance away from here, and as you go this way, you're actually pulling on both of those, so you don't get as far, and then you get farther out as you're pulling away from that F, and then you're going to both of them, and it works that way. Semi-major axis is the distance between the center of this oval and the farthest outside point. It could also be this side. Okay, so we go back to this. If you take a look at it, we actually have these AU values, astronomical values, based on the semi-major axis. And basically what's all based on number 1, or 150, the Earth, 150 million kilometers, 93 million miles. So this is 72% of that, that's 39%, and that's 39.5 times that value. That's for all the planets. If you want, you can just look at the terrestrial planets and see them. You can shut the terrestrials off, look at the Jovians. You can shut that off and look at Pluto, or you can throw all of them up there. I guess right now you should probably take Pluto out, but we're going to leave Pluto in. Orbital period, this talks about how long it takes to go around the Sun. 1 Earth year, that's the standard. Takes 62% of that one, so about 7 months for Venus to get around. Takes almost 25%. 3 months for Mercury to get around, so it goes around just about 4 times in one of our years. Takes almost 2 years, almost 12 years, almost 250 years for Pluto to get around the Sun. So humans couldn't have a birthday there. If you actually lived to be 84, let's say 85, you'd have your first birthday if you lived on Uranus. 29, you could probably have 3 birthdays there. 12, you could maybe have 8 or so birthdays. Can you do that? That'd be living a long time. It's between 6 and 8. Here you'd have half the number of birthdays you are right now. There you have the same. Here you'd actually have about 1.4 times, and in this one you'd actually have 4 times the birthdays. So you could have a birthday every 3 months if you lived on Mercury. Mass, by far, Jupiter is the most massive. Okay, you can see Earth is 1, 300 and almost 320 Earth masses. You can see the Jovian planets are pretty massive compared to the terrestrials. And you can see poor little Pluto with tens, hundreds, and thousands, 2,000ths of an Earth mass. Number of satellites, Jovian planets, a lot more satellites. Pluto, we actually just discovered a new one, so it's up to 4. I think we've actually probably discovered more for all of those, but Mars still has 2. Very minuscule satellites. Earth has 1, Venus doesn't have any, and Mercury doesn't have any. Density, Earth is the densest planet. We finally win. We're at about 5.5. Starts out at the crust at 2.7-ish. Actually throw the atmosphere in there less than 1. Throw the water in at 1. Average all those, including the 13 and 14 gram per cubic centimeter, which is what this unit is in, core, and we average out to a 5.5 for our whole planet. Mercury, the second most dense, makes sense because it's closest to the Sun. You'd expect that material to get pulled in toward the Sun. Not a whole lot of difference between those 3, and then we get down to about 4 grams per cubic centimeter for Mars. Jupiter, 1.3. Coolest thing about Saturn is less dense than water. If you could find a body of water like a bathtub big enough, Saturn would float, and it's the only planet that would do so. And then radius. By far, Jupiter is the largest radius. Again, we're using Earth radii. Venus is our twin, almost the same, 50%, 40%. We're up to, almost, let's say 11 times larger, 9.5, 4.5, 3.5, or almost 4, and then not even a quarter. Okay, that's it for this site. This one also from the university, and I'm going to change this HTML to SWF, and what that does is makes it larger. You can actually, if I go back to this site, you can download that shockwave right there if you want to, and there's also a Word document to try to see if it makes sense to you. Let me go back, let me go forward. And what this does is saying the temperature of where these planets formed. Third rock from the Sun is the Earth. We formed at around 600 K. And if you actually take a look at that in terms of temperature, that would be minus 273, 327, something like that. These are not degree, these are just Kelvin, but it would be 327, 327 degrees Celsius. So this is where our planet formed, and because of that, we actually were able to get iron sulfide to be a solid, feldspar, the most common mineral, to be a solid, silicate, the second most common, iron and nickel, as well as iron oxides to actually be solids. And then gases, we can have water gas, which allows water to get into our atmosphere to rain down to give water to the dry parts of the planet. Ammonia would be a gas, methane would be a gas, argon and neon. We don't really have much of these last three, but if we did, they would be a gas. If you actually go to Venus, which is warmer than us, now that iron sulfide is actually going to be a gas. If you went all the way over to Mercury, you'd find out the two most abundant elements on our planet would be gases, and all you'd have is metallic surface. If you went all the way out to Jupiter, if you could actually make the atmosphere that cold, you could start to make water as a solid. So that actually may be part of their continents. And then you can actually get colder, go out to Jupiter, and you can get ammonia and methane. And then you get the two methane planets, and then you can get argon all the way out to Pluto. And if you went farther out, notice you don't really get to 0 Kelvin, but you can probably approach 2 or 3 degrees Kelvin. So this actually shows you why the planets are what they are, where they are. And it all has to do with where were they when they formed, in reference to the Sun. Okay, thank you much. Bye-bye.